Okay, so welcome everybody. Zero code-based metadata-driven data pipelines automation. So one more time about myself. I'm Abdullah Mamun. I live in Munich. After finishing my graduation in computer science, I started my career writing algorithm for CBS database. And then I worked to migrate a small tech application to enterprise Java backends. I was hired for telecom project to build a very low latency API integration using C++ and Java. And next I work for banking credit API to build a real-time integration with mainframe third-party systems like embedded insurance, sports system, anti-money laundering tools, and so on. Now I'm busy for data and machine learning and analytics space. As a part of my career journey, I work as an engineering manager, product manager, software engineering, and I love to do it. Still working a lot for software developments, and I have around 4 years of project experience. Now I'm giving to Arif to give his introductions. Arif, please go ahead.
Yeah, thanks, Mamun. I'm based in Leicester, UK. So I'm myself having 17+ years of experience in different domains like network, data warehouse, telecom, BSS domain, and cloud computing. Majority of my career is spanned engaged with Ericsson, the largest telecom technology solution provider in the world. While working with Ericsson, I had the experience of working for worldwide operators like Vodafone, Telenor, Etisalat, Orodo, Airtel, Almada, etc. for their different type of complex solution design, development, and support activities. I'm currently pursuing a master's degree in cloud computing at University of Leicester, which is expected to be completed in September this year. I have 2 years of experience in Clojure for scripting, automation, and backend development. Mamun, please go ahead for the next.
Thanks, Arif. So this is the agenda. As a part of today's agenda, we have 5 sections. We think people come to Clojure community when they have a pain in software development, right? So we'll deep dive the purpose of data pipeline as a part of source of pain. And Clojure community is amazing to solve different kind of problem. We all know it. And I have learned a lot from Clojure community. Next, we'll deep dive metadata and metadata systems and tell why it is important and how it can make our life simple if we use the metadata as a part of pipeline. Then we'll go through Koli and its feature as Koli is 101% Clojure application. Front-end, backends, DSL, Koli compiler, CI/CD pipelines, all are written using Clojure. We'll share designing and development experience as a Clojure for Koli. And we'll see a different deployment option and uses for different users. And finally, not last but least, we'll show end-to-end demo to build a streaming database, data warehousing, using data vault models, and knowledge graph for semi-structured data. So if you look that today enterprise applications or setup is really complex. And today we need to a lot of things to run business digitally. Our business is also changing continuously. Company need to build many type of sales channels like direct customer, indirect customers for B2B or B2C. Technology stacks is growing more and more and need many types of tools and skills for data analytics, machine learning engineer, and process mining. And everyone needs something very common to know, like as example, semantic meaning of our business. Like if claim is open, then what does it mean for machine learning engineers, right? When claim is open. So building source of truth. If claim open, then what informations do I need additionally to do my job for analytics? And like customer identity or product information. Finally, how do I represent it better way to access for the people or machine? So machine either it can be machine learning engineer, process mining, and data analytics. This is a huge challenge in industry. But in reality, it is not so easy to achieve it in the context of budget, time, and effort, right? And if I look from the top view, like when I worked for like engineering manager for the multiple time, I found that there are a lot of duplicate business concept in code. So machine learning guy is writing a concept that is same duplicate concepts of data analytics guy, and repetition cost for duplicate implementation, invalid data set, and then duplicate data quality rules, and duplicate transformations. Like one place there is the transformations, and another guy is using same transformation in a different way. And changing upstreams, it's always breaking the downstreams. Something is missing, right? And long-term maintenance cost is so high in enterprise, then sometimes we identify that, okay, let's start new developments and just decommission all the whole thing. This is the regular things in enterprise application, right? And we are using multiple tools that need to learn and be experienced for the best practice. Then I really asked myself, why it is like that? Why we already have a lot of amazing tools and technology, but why it is like that? But I really found this is the things that we are skipping a lot in industry, like silo overview of inter-business concept, lack of proper uses of mutable and immutable data source, data quality ownership, like who are really the owner for data quality. Like as example, email has a semantic meanings of the regular expression. So email semantic expression of regular expression is changes. So who are the owner to change all the data flow for machine learning, like process mining, or anywhere? Who are the really responsible? It's completely missing. Fail to define right source for the duplicate transformations. So like some data is in streaming, some data is for the data lakes, or any other place. So what are the right source to apply the transformation that can work for all the places? So changes in upstreams break downstream. That means that there is a mapping layer is completely missing, that people are using the source that always broken. And need to maintain many tools and process. Like when we don't have any unifications, then as a part of engineers, it's always need to maintain many tools and process, and it's expensive. And fail to focus on business use case, as we need to learn a lot of tools and technology for it. So I'm going to next slide. So most of the application, hello world example, as example, machine learning, Java, closures, all have a hello world example. So this is a hello world example, and it is driven from one real example that I have worked before. So here I can see the party entity has a list of objects of person ID, F name, L name, email, etc. And bank info is another entity which contains bank info details with person ID. Address is same as the bank info, and contact containing person ID and contact ID. Finally, claim contain contact ID and claim ID. Please note, all the field is in here string types. So this is a model representations, right? To build a different type of business implementations, I need to represent my model in a streaming database, database model for data warehousing, graph model for knowledge graph, a Parquet file for machine learning or something else, right? It's really not the thing that out of box that I can do it. So first I need to represent it to do my job. First, without representing it, it's not possible to do anything. And most of the time I need to learn new tools for different type of solution. As example, for data warehousing for one tools, knowledge graph for another tools, or maybe virtualization, or semantic layers for another tools. But there is no way for unification for simplicity, right? And this is like one of the transformations patterns that we all know from internet. So this is an example of transformation from source layer to the target layer, where I need to define or create injection table that is one-to-one with the source system. Then refine layer, basically this is a mapping layer between the injection model and refine model, and for the harmonizations. And finally, feature layers that get a real business insight. So if I look internet, this type of emails you'll find for Databricks, Azure Amazon Glue, or Azure Synapse. But all that's very look simple, but in the code, really it's so far away from to make it happen or do it. And not only for the data flow, but I also need to apply data governance things to consider. As example, the data quality. So if date of birth is string types, so expected type, it should be date type, right? I need to convert it. So if email is empty, it should be valid based on the regular expressions. If gender need to be harmonized based on the reference data. So either it can be M for male or A for female, or 0 for male or 1 for female, or whatever. So it's need to be harmonized based on some reference data. And different type of amount strings that also need to convert it to the decimal. So there are all the data quality rules I need to apply to build something new. So these are the one data flow is a streaming data flow. I'm sorry that image is not visible, but you can consider that here is a one raw layers, define layer, and there is a link. So if you really zoom in, and then you can see. So these are the different type of streamings, like it can be event, streams, or table. And in here, it's around 25 models. And I need to write a lot of query to do it. It's like for on simple applications, it can be like 200 lines, 800 lines, sometimes 1,000 lines, depend on the source code, right? And I would like to focus on error models. Look, this is a DCP user error. I mark it in here. So I would like to deep dive only the error source code and to see the complexity of whole workflow, just grabbing only one. This is the data flow for error model source code. Here I can see data is inserted to the error model from the party, where email is empty or wrong format. I can also see regular expression is using where condition, also in a select statement. So I need to update regular expression for email when I need to look up multiple places of the source code. As I am not working for the semantics of data quality like email and customers, I need to look up for the source code to find all the regular expression to change it. I also need to convert string to decimal type, and schema changes mean I need to rewrite all these things again, right? Finally, I need to be experienced to solve this type of problem, because if somebody knows this, like any time of tools, it's really hard to write this type of statements without being experienced. This is a really huge challenge, right? To make it data flow workable. So this is just one example of error model. And when I look this like data flow, it's a huge complex things, and it's technological driven instead of domain. So when it is made, people are focusing more on the technology instead of semantic of business, like email, customer names, and all others, and instead of domain. And seems like nobody can tell that it should be mutable or immutable. So example, this data flow. So one time it's run in the production system, what will be the flow? It will be mutable or immutable. So if it is immutable, then how I can apply new versions for the new data flow? This is really hard to define without automation. The next is how I can manage the versions. This is really already complex. So I have the injections table, refine model, and feature layer. I would like to manage version for a specific part, how I do it. And so writing a code, it's really hard to managing versions. And next is like how I can make a scale up. Like I would like to test this data flow for one machine. I'd like to scale it to many machines, maybe 1,000 machines for the production stage, or for the staging script for the testing. I would like to apply do it. It's really hard to do it. Then I need to go all the streaming source code, and I need to change partition replication factor to make it for run for the many machines, right? And it's like clone and deploy whole workflow. Like as an example, the GitHub, like where I can clone the repository, I can just run it. But for this streaming workflow, and it's not the software environment and CI/CD pipeline that is really impossible for streaming flow that software they're providing to clone and deploy it for my environment. It's really impossible, right? And like drop and update refine, like without deleting it. Like as example, it's refine layer is wrong. I would like to rebuild refine layer without touching injections layer at all. And it's extremely hard when I'm writing by hand or using some software, so there is no metadata, right? And then I would like to apply this glossary lookup. Like I would like to find something like, okay, this first names, why it is, email, why it is. It's impossible when you're writing the code. We need to just look up some shell scripting to find this type of code, right? And this is another part of data flow connectors, as we have seen that as a part of, this is a list of connector from the Kafka, but it does not matter. If I work for a data factory, I also need to learn different type of technical stacks to build the connectors. But this is the same thing as Kafka, and like, as a data factory or like Kafka. I need to provide a schema name and all the transformation logic with every connectors, right? I need to apply transformations knowledge, like, okay, how the field name it will be for the target layers, or it is a knowledge graph, and so on and so on. And I found that 80% of the duplicate code within all the connectors. And in the end, this is a timeline is coming from the Confluent. All the Confluent, they have simplified a lot for the cloud, like Confluent Cloud, like 3 to 6 months for app development, not managing Kafka, but still it is a lot. So using the metadata processing, we will show you that we can start or build application within a minute as a part of the demo, and we can build a streaming deployment in a day. It can be very complex. It can be for the data warehousing, or it can be for the knowledge graph, or streaming analysis. So we can do it in a minute instead of 3 to 4 months. So, and as a part of, so first then we need to understand, like, as it is for the metadata processing, I'm giving it to the Arif to tell about the metadata slide, explain the metadata in the next slide. Arif, please go ahead for the metadata.
Yeah. Thanks, Mamun. So let's deep dive into the metadata concept, or where is the metadata exist basically. So can you please go in the next slide? Yeah. So, I mean, if you see on this slide, basically we're trying to see where is the metadata exist. So metadata is about data. So it exists basically in any system, like relational database, in the machine learning or Kafka streaming, everywhere the metadata is exist. So what we're trying to see, how this metadata we can use it, how this metadata is being used in other systems like Snowflake, SQL DB, so everywhere. So I mean, let's see on the next slide, we're gonna see how we use this concept. On the left hand side, we're trying to show a traditional application or where the metadata exists. But now on the right hand picture, we are trying to show that we are bringing the metadata concept close to the business. So on the top layer, the business domain is there, and we are bringing the metadata repo from all the source, bringing to the close to the business. And from the metadata repo, we are generating code for our downstream system, like data warehouse, like machine learning feature, like Kafka streaming application. So by using this metadata concept, we are simplifying the app development process, and we are reducing the timeline as well. Can you please go on the next slide? So on this slide, we are basically explaining our application, the Koli architecture. So how this Koli architecture is, I mean, doing these things seamlessly. So if you see the center of this application, diagram is the Kafka cluster, which gets data from the source database, and also the sync connector is using to extract the data and transferring data to the target database. So on the top, you can see actor or user can log into the Koli application, and it can import a semi-structured data structure, and then the Koli application will deploy the KSQL code in the Kafka broker, Kafka KSQL DB. So Koli, basically heart of this Koli application is the domain-specific transformation, the DSL language, and also we can generate the connector template to see the data inside the Koli application. So in a short, Koli is an intelligent data pipeline app which builds reactive data flow processing by processing metadata. Before going into the further part, Mamun will deep dive the mapping part of the DSL, how things are working inside the Koli.
Thanks, Arif. So mapping helps to link between layers. As example, that I have the source layer, it represents information in a way that's good for the transactional model. On the other hand, I need another model that go for graph or column storage. So mapping create a link between two models to build a streaming data flow. As example that in here, person forename is linked to the person refined first name with the joint bank information. Our address is coming completely different data source. So Koli mapping is just nothing but data flow DSL. So let's deep dive this mapping DSL one by another. So this is a triple model. So triple has a like subject, property, and object. So this is a RDF like a model it's using for the knowledge gap representation for the data, but in Koli, RDF is using for this metadata representations, right? So when we have an example that user has the entity or subject, and it has a first name as an attribute. User has another attribute, last name, and object is nothing because there is no data source for it. It's just a schema. And by using this compiler, it's possible to generate schema generators, schema visualization, and KSQL runtime code, right? So when I have a mapping, that it's possible to generate multiple things. So this is a code KSQL code generation. So example, when I have users, and then its name is corresponding this streaming code, and then corresponding attribute its name is generated based on the property name of the mapping, right? So F name is coming F name, and L name is coming L name. So it's possible to define the type in here. So here is the integer types. It can be array, it can be a start, or it can be anything complex, complex data type. It's possible to add it in here. So when it is integer, I can see that age integers in here, age type is integers, and other information same as the before. And then this is a really mapping layer. This is the fundamentals of Koli. And also I think it's very important to needs for any data pipelines automation. So as example that user defined first name is mapped to the user F name. User defined last name is mapped to the last name. User defined age is mapped to the user age. And when I look this statement that it's using the select statement. So F name is mapped to coming from the first name, and L name is mapped to the last name. I can also apply concatenation function. As example, when I erase this entity or I would like to build something new. So I can, as example in here, full name that I would like to apply concatenation, F name and L name. So this is a really closure function, right? So this transformation is a closure function, and this transformation has a different senses, and then corresponding KSQL code is user F name and user L name to build a full name, right? And then I can also apply while conditions. So when it is while condition, that means there is no property. So while condition, having clause drop by, there is no property. It's simple, then I need to put the nil entity in here. So when I do it, then I see that corresponding while condition is also attached in here. Like, so if it is length, is like first name length is 0, then I'd like to filter all the data from in here. But in the routings or like in a data flow, there are a lot of complex use cases. So what are the complex use cases in here? Like when I would like to collect data from user to user refined for the valid data or invalid data, I can apply while conditions. But when I would like to route data, that means if it is the user as a valid, it will be go to the user refined. For invalid data, it will go to the error tables. So error tables, I can move it to this cold storage where I need to pay less money, right? And then claim is same. If it is claim data is valid based on the data quality, it will go to the claim refined, and claim other data should be the error table. So error is a very generic schema, and they're possible to map any schema like user claim or anything to the error schema to put on invalid data in one place for the next analysis or for the remediation process. So to acid bit, it's just one syntax enclosure. Like this is a while plus, this is a macro. Macro in the syntax, if I write a while plus, then the code generations of the error is automatically generated for this schema without writing anything, right? This is the things that how data flow is simplified. So in here, there are two schema, right? One schema is refined, another is error. So refined schema is containing all the valid data sets, and error topics is just the reverse, like once complement of the source of truth to collect all the data that is invalid and store it in here as a general schema. So now I'd like to give a very simple mapping demo. In the end, we will give another demo full end-to-end, but here I would like to give you a very small demo to give you flavors how really reactive code generations and real-time it's work. So Koli has a two environment. One is like zero code-based approach, another is the DSL. So now I'm going through the zero code-based approach to show it how really it's work. So this is one application. So now I'm running in a locally. So here there are two login. So one more thing, this application 100% is written using closures, right? This is the front end, back ends, everything is written as closure, CI/CD pipelines, everything. So I can log in here, one-time sign in as a part of memory storage, or I can log in using the Google for the persistent storage, where I can store the information, I can come back and work on it. So I'm logged in here on-time line for in-memory storage. And I can see in the left side a lot of things, but I don't need to focus on it right now. I'm interested in only this part. So I'm going to import a JSON files in here, as example, person.jsons, and immediately I can see this visualization in here of my structures. And I can also look SQL code, corresponding SQL code is generated. Just without writing anything, I can also look, glossary attribute is there. All the glossary attributes is there. I can search in here like total, and I can find this totals information in here. But as my structure is semi-structure, this is just a hello world example, right? It's a semi-structure. I need to apply flatness operation on it to build an additional model. It can be graph model, or it can be like datable model. But this model in here document. So I am applying, right-clicking and apply the flatness operations on it. And now I have a new schema that has the flatness operations, right? Now I have a new schema completely has a visualization, and I can see this SQL code also generated automatically without writing anything, right? And this code also can have a duplicate data set. As an example, that when document storage is coming a duplicate data in the pipeline, I would like to remove all the duplicate data, and I would like to keep only the distinct data set for my target storage. So I can apply the distinct operations in here, and I can tell, look, I would like to apply distinct operation all the entity that has postfix row. So by clicking it, I have a completely new source. And if I look these visualizations, I have a full distinct layers. Yeah. And then I can also see this SQL code is all this SQL code is generated. And this is amazing that how much code is generated, and people will just feel crazy to write it. Even you learn it many times, people will fail because of the experience. Yeah. And now I can see this is a Confluent platforms. Here is no data flow, right? Everything is empty. So I'm going to deploy it in a data flow in a minute. I'm going to deploy this data flow. And now I can see my data flow is generated, just is out of box, just by doing nothing, right? Now I have a full data flow in a Kafka to build something new end to end, right? It's not only build the data flow, it also creating, like you see, there's a lot of stream is generated, and stream is generated based on the best practice that come from the Kafka, right? Organization name, namespace, and entity name. It also creating a table for this, like storage. It also created the topics. And if I go to the topics, and if I also go to the distinct layer, you will see that schema also generated. Like everything is automated inside Kafka without writing a single line of code. Amazing, right? And then, okay, now I have some things in here, but how I can build a refined layer? So where is really mapping is coming? So any ETL's pipeline, it's not on the Koli, but if you go for the Amazon Glue, if your Azure Snaps, if mapping is missing, then it's a big mess for the business application development. Mapping is the fundamental for decoupling applications. For one is for the metrics, another for is for the source of data, right? So I'm opening this one as example to build a mapping layer. So as example, I am opening the person party in here. I can tell, you see this, all the field is automatically mapped in here, right? Now I can say like this is the party information, and I can build a refined layer, party refined. And I can tell this person ID is required, and I can see this corresponding code is immediately generated. I can also tell my L name is the customer name, and I can see this code is automatically incremental generated without writing anything, right? And I can also see this email in here put, and I can see this corresponding SQL code is generated, right? And all this, like, but from where this email is coming, I'll go for the next step from where it is coming. So what really is in here, this is the things that we are trying to build. And this is the thing I am struggling a lot in data pipeline. Here is the things decoupled. So who are working for the data quality, they are working for the semantics of defining this, like the semantic, the type. So the type in here, like business type, not specific like Kafka or technical things like integer string. We are using in here like email, customer name, policy number, claim amount, claim. These are the semantics here. So when I have this, and if this email semantic is changed, the code in here automatically changed. I really don't need to think about that. What will be the semantics validations rule for the email? I will see in a minute. And then I can also defining this person ID and person ID in here. I can see that code changes in here. And now finally I can say, okay. And now I have a party defined layers, right? So now let's check about this email. Now in here, like email is say like, okay, it is more than one. Now I'm going to change my email validation logic in somewhere else. Who are the responsible for the data quality? Who are not responsible for the modeling part, right? So I'm going to the logical types in here. And I say, look, this is my email type. This is the regular expression for email. And this is the length. So I say, no, this is not more a 0. My email regular expression now is 10. Yeah. So, and then we don't need to look up the source code, right? If I go in here and if I go to this SQL code, wherever using this email, it's automatically changed and reflect in the source code. And we don't need to, people don't need to look up specifically source code and regular expression to manually change and apply CI/CD pipeline, right? This is the big things, like put things apart and glue them together. That we learn from the closures, right? So mapping and then data quality it is a different part, and then we are glue them together. So now I'm going to deploy it. So now so far I don't have any defined layers in here as a part of this flow, and I'm going to deploy it. It's an incremental deploy, so I'm going to do it, and now I can see this. My refined layer is generated automatically, right? So this is the part is defined and error. So if the data is error, then it will go to the error topics. And it's coming from this, right? So these are the things that is coming from the distincts, right? So refined layers and error all are coming from the distincts layer. Now I'd like to apply and push some data and let's see that how really it's working. So I'm pushing some file in here. And I can see like person file in here, data preview, and I can see the data. And now I can also see that person defined layers is also this data, right? Now I am pushing another file in here, a duplicate file to see this how duplicate distance is really working. So now I can see this raw. There are a lot of entities in here, but if I see my refined layer, it's only one because all the data is removed and the duplicate, right? Then I can download this data as RDF format, JSON format, CSV, or anything else. So I'm just clicking it. Sorry, I think, yeah, it is load. Yeah, I think, yeah, if I open it, then I think it will generate the RDF file. Sorry, I need to open it in another application, so I'm skipping this part. So this is really a closer applications, right? A Koli application to put things separately and do this. So if I click a data vault, then it will create automatically a data vault transformation for the refined layer without just writing anything. So I'm clicking this data vault and I say, okay, apply all the refined layers. Now I see that Haven satellite is there, right? Without writing anything. So if I go to the source code, I can see that my data vault layers also available. And this is exactly this our purpose, to using on tools to solve multiple problems. Data warehousing problem, streaming data buildings, and knowledge graph building, just one tools, and this need less experience and for to do it. And I'd like to maybe not going for deep diving another for like another part about this, how we can using the code-based approach. But before that, really, I would like to apply another things like how I can manage the versionings. So as example that I can build another version without just doing anything. So I'm clicking in here. I said, look, my user two now in here and save as. And now if I look my SQL code, that now I have another versions and I can deploy this without doing anything. Now I'm deploying it in here in a Kafka, and now I have a two version of dataflow. So two version of dataflow where I can tell from where I would like to collect data, right? So this is a immutable data flow. You don't need to break your previous one. You can go for the next step, still keeping running your old data flow. This is a big things, right? You cannot do it simply with any other systems like Amazon Glue or like as a snaps, right? So to build to data flow, just copy paste and build a new version on it. And on the top, like here is some API playground is there, like some internal structure, how it is. And then I can also apply connectors in here. Like if I apply this connector, there are different template in here. And I can say like how I can apply a template it in here. Then I can also define runtime configuration, but I can say like to which Kafka I would like to deploy it in here. It can be Kafka Confluent platforms or on-premise services or testings, whatever purpose you can define it in here. And also like different type of runtime attributes. I'm not deep diving this part. This part need a little bit learning, of course, for this like datable model, these things, all of other things. Yeah, replication partitions and all other things that is there. On the right side, there are different type of operations. So if I clean it, then in one shot, it will clean whole like, sorry, I'm sorry. So it will clean a whole Confluent platform just by one click. It will convert it to the zero state to make things and make it very user-friendly for the developers and for the corporate Confluent experience, right? Okay, that's all for as a part of the demo. And so I'm going for the next slide now. So Koli features, so it is a metadata-driven data pipeline automation that I already have shown. So you really don't need any technical experience. Only you need to understand for your business representation and business model to make data pipelines happen, right? Then it has a metadata crawlings, metadata harvesting, and transformation. So anyone can upload metadata for visualizations from any source, XML, CSV, JSON, or connect to any source to visualize metadata and see really what is theirs. And then code generation is there as example, SQL, Schema is there, role management is there. So if people, somebody can define, okay, this is the admin who has a configuration of security key, and somebody can working for the modeling, and deployment can have the admins, right? And then data quality, same as the Clojurian specs. We have seen this email, but maybe I can deep dive later, maybe in another day. And domain type like customer name, insurance price, email. So now, like in Koli, you don't need to working on a specific like language specific integer strings or others, but normally in here we're working about the domain types for the semantics of the data validations, right? So data visualization and the tabular view. In the future, we're going to release as like real-time graph view and different format of metadata injections. I already mentioned XML, JSON, and CSV file. Synthetic data generation is coming. As example, when we have a metadata and schema, it's really apply the synthetic data generations out of box. And to push this data, any system like either data warehousing or like knowledge graph or whatever. And integration with any Kafka service, either it can be Confluent, or it can be on-premise, or it can be just local systems. And finally, RDF trouble, just mapping DSL. So now we are coming to closer for Koli, right? So this is the things like the talk. And for this talk, really, if I go, then there are a lot of things that really I would like to tell, but for the short times, it's really not possible. Maybe another times I'll go on with these times, like why Clojurian is so important to build applications, not to go for any specific part. So first thing is, if there is no closure, then no Koli. I don't think it's really possible to write Koli without closure language in the context of time and budget, right? To cover all of my experience, I need to do it like another full day presentation to do it, right? And like how, from where UI concept is coming, right? So we are not copy paste. We are not looking any like data pipelines automation that as snaps or like Amazon Bloom or any other talent. So we think that we need a different UI. So how we build a requirement for UI. So as example, we have analyzes the SQL statement that Kafka, also Spark, or any others to how they are really building a streaming flow. As example, this is the one of the example here, create streaming DCP customer user defined. So DCP is the organization name, customer is application name, and here is like event. And these are the storage information, like topics name, what will be the value format, and these are the things that disaster recovery for this partition and the application factor. And in the below is the model mapping things. And then we figure out that we need to something like that, like to build a UI, not to look a UI that already exists and just copy paste this UI. And this is exactly that meaning that what the creator of Clojure is hacky, he design mean this, that, like design mean putting things apart and compose them together, and that things can change independently. Actually, this is the mean of Koli. Like configuration is the one thing, mapping is another thing, and data quality is another thing. So I can sense data quality independently instead of thinking my modeling in anywhere. I can change my configuration to deploy the things, my staging, productions, and anywhere, and people can have independent responsibility to do that. And when you're using Koli, then we are composing, like Koli composing this thing to build SQL code, schema visualization, and a schema. This is a simple problem, right? And this is really mean the Clojure, right? If you're using the Clojure, this is the thing you need to understand, that how you will put things apart and build them together. Doesn't matter it's Koli, but it for any application. When I'm going for machine learning development, I really follow this pattern. How I can make things apart. And this is UI, and this UI and whole applications we are working for two developers in here. I think we have spent around 6 to 7 months in here, but as a regular development, but we built in last 1 year and 2 months, because we are working in here ad hoc basis, not continuous development, as a part of holiday times, in afternoon and free times. So if we work together, like me and Arif, then I think we need 6 to 6 months continuously to build this whole workflow and whole applications, right? And this is 100, although it's marking 100% Clojure app, but for me it's 101% Clojure application. So UI, we're using Clojure script definitely, and library we're using Material UI, Vega Lite, and front ends Clojure script again, and as the framework we are using Reframe, Reddit, and CLJS for the communications. Backend development, backend also Clojure, core async, pedestal. I think most of the people in Clojure, they know it, this type of library. Normally people are using it. So database, we are using data script, and for the storage, we're using as a blob storage for the data script that put the snapshot on here when the application go to the offline. And runtime environments, we're using Heroku containers and Azure CDN content delivery network for Clojure script file, image, and all others. Let's go to the devs, right? And build and CI/CD pipelines, we're using GitHub Actions, CLD tools, and Shadow CLJS to build whole CI/CD pipeline and deployment. So one part really I need to cover, because I'm not going all the specific part of the applications, but this is the part of the decisions really everybody need to think about, that how really it really work. Koli has a state both in client and server side. So if user browser is hang and close the browser, user can get back his state after opening it again, right? So what is the really biggest challenge for a client-side state application? Is it API or build a state in the client side? This is really the big question to us. What is really important, to build a state in a client side or to build an API? And we found that huge challenge is in here, how we can build a state in client side for client side application, or like single page application, or it can be partial single page application. This is the big challenge, how we can do it. So to do that, we have analysis like GraphQL, we have analysis like Swagger's and many others, but we decided to write it by ourselves, a very simple, in a closer way, just removing all the complexity. So what I did, we write an invoke API on the client side, another invoke API in the server side, and we put all this complex network communication between these two invoke. So that means HTTP client, HTTP client, socket, whatever, maybe another web push. So we can integrate it any kind of like system dependency library, this between two invoke, and our application layers always isolated. They don't need to know like this communication is HTTP, socket, or another way, right? So invoke is the abstractions of server and client for to maintain front end and a build a state, right? And it maintains all the communication type and all the maintain. So it handles the error code. That means if the error is happening, it's a JVM error that we can display in UI. It's a very nice descriptive way. So don't need to understand that, okay, what is really happening in the error in the backend side. So of course, serialization, that standard serialization is the code that have. That sorry. So streaming data, I already saw that how we can streaming data from the Kafka to the Koli by just a short data, right? We have seen it. And then server-side logging is really very simple because it just has a one API, and the authorization also very simple and reduce dependency on the library code. As example in here, as it is really only one API for whole application, and all the library code only in the invoke. So I can change, or we can change it to the new library. As example, if you see the pedestal is not maintaining in future, it's just one namespace where I need to upload the code, and then I have a completely new library with the new, maybe with a new feature, with a new performance. I really don't need to touch my application code at all. I think these are the one of the patterns that really everybody think about it. Invoke is just nothing, but invoke help us in here to build how to build a client database that can render our UI, right? This is the thing that the hardest part. And I think also that people need to change their mind. Instead of thinking that client-side API, we need to think how we'll build a client-side database. This is a big thing, right? So this is on source code. I bring it a lot of source code, but these are the funny things that how maybe in the server side, I really only have a one route. This is pedestal route in here, inbox. And I said that, okay, these are the method name and routing it. This is just only one route, nothing else. And then I have implementation of the method dispatch. I can tell in here the API name and the request format. And in the client side, I have a reframed registrations, register events, where I can apply register this invoke API. And then I can apply different type of invoke event to call this server-side event. So either it can be Ajax, or either it can be like a socket or a server-side push. So this API, it does not care about what are the really technical implementation of it. So then my application code, I am focusing more to implementing the business feature, not any technical things. Like I don't need to think about this pedestal routing complex things. I'm focusing more about to implement a new API that fulfill my new business requirement. Same at the client side, I'm going to implement it, or I'm going to use new API in here to provide a new feature for my UI layers, right? And this is how we are using generated as a service. So this is another part, right? The state in server side is basically a tree. So as example, we have a repo layers. Repo layers containing namespace. I have shown it before that I can clone the namespace, or I can copy the namespace to build a new namespace to build another versioning of our data flow. And namespace containing schema, type of data quality, and configuration. So when there are some front-end event is happening, it always comes to the namespace. So namespace is the container to keep all the things together, and then it will execute generator services, storage, security, all other things, and build like runtime code like SQL visualization, all other things, and push back to client side instead to display it or render it in the client side, right? So two users can work on the same namespace, or two users can work on the multiple namespace. So it's different how then based on it, this UI, it will be displayed like that. So now I'm giving to Arif for the next steps and deployment and all other things. Arif, your turn, please go ahead.
Yeah, thanks, Mamun. So Mamun, I mean, super, he already explained part of the Koli in internal architecture, how DSL work, how mapping work. So now let's talk about a little bit about the deployment. So how we can deploy this application. So we can deploy this application on SaaS solution base. Also, we can deploy for the development environment as a jar application or Docker container. And for the production purpose, we can also deploy in the Kubernetes application. So in the Kubernetes application domain, let's say we have the Kafka cluster or Confluent cluster, and then we can deploy our Koli application and then do this business automation very easily. Also, as we already told in before that Koli has a in-memory storage, or it can use file storage, or for persistent purpose, we should use, I mean, like cloud storage like S3 or Amazon Azure Blob. And also Koli support OAuth-based authentication like Google or Microsoft. Just also it can support one-time guest login feature to just see the feature, how it will gonna work. Next slide, please. So now, I mean, we're gonna see a little bit end-to-end demo, like, I mean, and data board, I mean, model, and the knowledge graph model, how it's developing. So I'm going to share my desktop.
The country field is available in refine and listing layer automatically. But most of the time, I really don't want
Can you
to
see, I
write
mean,
any single line of code. Now
Yes, I can share it.
okay.
Here is a simple sample XML file. It containing book ID, author names, title, etc. I'm importing XML file. Immediately, I can see schema visualization and corresponding code. I can also import CSV file, and I can see corresponding schema is generated. Now I'm going to show how to build end-to-end data flow without writing any single line of code. I would like to build data board model, graph model from the same structure JSON file. In this file, I see party is a single object, backend is the array of object, address is the array of object, policy is the array of object. As a part of the validation, I can see email is empty, all the field is string type like premium commission, it should be decimal. Here my metadata visitor is empty. Using Kafka and SQL for streaming, I see there is no streams, there is no topics, and of course there is no connection. And my Postgres database is completely empty. And finally, I see my graph database also empty. There is no node. I'm importing JSON file, and I can see schema visualization. And then I'm applying flatten pattern on the menu, and I can see the new schema. I'm applying pre-built distance operation to all the schema that has prefix row. Here is a SQL DB code generation. And I can see a lot of code is generated by single mouse click. Now I am opening a smart mapping UI to build refined schema, where I can select all the fields, join new schema, condition, many others. I can see all the fields are already mapped by default. I'm changing field type for first name, last name, date of birth, email, and sex. By clicking generate code, I have seen a lot of code is generated. Finally, I am clicking OK for new schema. And in that, I'm repeating this smart mapping UI operation for address, policy, and claim. I can see my refined schema for address, party, policy, and claim. I can also see visualization of my schema. Before deployment, I'm checking my runtime connection and configuration. I see that all server status is okay. After deployment, I can see data flow is generated in Confluent platforms. I see person, person raw, person distinct, person refined, and error strings is generated. Like to create datablow schema from refined schema. After clicking datablow button, I can see datablow schema is generated in runtime as a part of incremental deployment. Now I'm pushing person.json file to Kafka. After finish, I can see data from person and data from address. Now I'm applying connector for hub, satellite, link, and error schema. I can see all the connector is generated, and I'm going to deploy it by clicking deploy button. I can see all the connector is generated in my runtime system without writing any single line of code. By clicking refresh, I can also view all the connector status here too. By refreshing database URL, I can see all table is generated based on my schema. I can also see data from the different table. Now I would like to see my knowledge graph. I'm executing a SQL query. There is a lot of instances of person address, person, and other schema. I'm selecting one instance of address schema to see relation. I can see address as a relation with person. I'm expanding node to see other relation. Side menu, by clicking metadata repo, I can share my repo with my colleague for working together. I can copy namespace, open namespace. Namespace is same as Java package. I can add or edit domain type by clicking logical type. I can change app runtime configuration like domain deployment URL, partition, retention, join window from runtime config. I can ask for new feature or create bug task by clicking open issue from menu. I can see example from community. Finally, everything is free to use. If you like, please click a sponsor button from menu. Thanks everyone. Hi all, to solve different.
So in summary, I mean, we have seen the video. Now in summary, as per, I mean, I already shared this slide before that as per the Confluent analysis, the streaming application deployment is gonna take 3 to 6 months. And then, I mean, the application will be launched. But here with the Koli, we have seen that we can start this Koli application in a minute, and then we can develop the event streaming application in a day or weeks, and who is basically in turns give us the reduced learning time, faster experience in the domain, automated business I mean representation, and focus on more on the business development rather than on the technology stuff, complex technology stuff. So let's little bit move on the next slide. It will be the final slide basically. So in this slide, I mean, if you see, I mean, we already, the Koli URL is here. I mean, you can use it for, I mean, experiment or checking. And then new feature request can be available in the GitHub. I mean, if you need, I mean, think that, okay, we need something. Also, if you see that, okay, there is some error in the feature, so you can raise the issue ticket in the Koli. And finding, we are also expecting a sponsor for a specific development plan for their organization. And for regular update, please follow us on the GitHub repo. Video link or this demo also available in this YouTube link. And the presentation tonight also will be available at the end of this presentation in the GitHub repo. That's all. Now we can have a question and answer section.